Okay, so in this example, we're going to be talking about how to use Pascal's triangle to solve combination problems. Now, technically, when you're solving these combination problems, what you're doing is you're actually finding the binomial coefficient, which is part of the binomial theorem. So just keep that in mind and understand that when you get to the binomial theorem, all of that actually comes from Pascal's triangle. So in other words, the binomial theorem is derived from Pascal's triangle. All right. And you can see here that I have Pascal's triangle expanded out all the way to the 8th power on my diagonal. So again, I'm looking at this diagonal right here, okay, because that tells us the power that we're working with. And I expanded it out all the way to the 8th power. So technically I have 9 rows here. And remember, you can technically expand out Pascal's triangle an infinite amount of times, but for the examples that we're going to use in this video, we're only going to need to expand it out to the 8th power in regards to that diagonal, okay? So why don't we go ahead and take a look at our first problem, and we'll talk about how we're going to use Pascal's triangle to solve these combination problems. So here's our first example, and it says the following. Dave is going on vacation in 1 week and has started to pack. He currently has 6 pairs of shoes, but can only pack 3 pairs. How many different combinations of pairs of shoes can he bring? Okay, so this is a combination problem, and this is where you can use Pascal's triangle, all right? And it's really simple. And if you didn't know how to use Pascal's triangle, technically you'd start writing down the combinations, and that can be a lot of work and it's easy to make a mistake. All right. But using Pascal's triangle, it's super easy. So the first thing you have to identify is what is your total, because that's going to act like your power. Okay. So my total here is 6. I can see that right here. Okay. Dave has 6 pairs of shoes. Then your next step is how many are you picking, or how many are you choosing? Well, Dave is going to be choosing 3 pairs. I see that right here. So that's all the information we need. And once you have Pascal's triangle, you're pretty much done with the problem. So what we're going to do is go back to Pascal's triangle using this information, and I'm going to show you how you're going to get the answer to this problem. So we're back on Pascal's triangle, and remember the total that we were given was 6, right? 6 pairs of shoes, and he's going to choose 3 of them, okay? So here's my total right here, meaning I'm going to use my diagonal and look for that 6. Okay, I see it right here. Okay, how many are you choosing? Well, you're choosing 3. So from here, it's super easy. All you have to do is count, and you're going to start with 0. So for example, I'm using this row right here. And starting at 0, I'm going to count to 3. So I'm going to say 0, 1, 2, and here we go, 3. There's your answer. There are 20 combinations. So if Dave has 6 pairs of shoes and he chooses 3, there are 20 combinations that can occur, okay? And you can actually do this in your calculator. So if you have a scientific calculator or a graphing calculator, you want to go to probability, and you'll see a choice that says N and then CR, okay? That's the option you want to use when you're doing these combination problems. So if you were to put it in your calculator, you would put 6 first. Then you would find this option in your calculator, and it's under probability. So you start with 6, and then you go to your probability menu and you look for NCR. And when you hit enter, it will give you NCR right after that 6. And then you would type in 3, just like this. When you type this into your calculator, it should give you 20. That's how you can calculate the binomial coefficient in your calculator. It's really straightforward, okay? But again, we're doing this by hand using Pascal's triangle. So why don't we go ahead and look at the next example. So here's our next example, and it says the following. A small dealership owns 8 different cars, but only has a 3-car garage. How many different combinations of cars can the dealership put in the garage? So again, very simple. Just look for your total. I can see that it's going to be 8. So I'm going to go ahead and underline that. 8 is my total. What am I choosing, or what am I picking? Well, I'm going to pick 3, okay? And again, that 3 is right here. So we're going to go back to Pascal's triangle and solve this problem. So let's go ahead and pull up Pascal's triangle again. So here we are at Pascal's triangle again, and the total was 8, and we're going to choose 3, okay? So again, he has 8 total cars, and he has a 3-car garage right here, okay? So use your diagonal. I'm going down. Here's my 8. All I have to do now is count to 3. And again, you're starting at 0. So 0, 1, 2, and 3. Here we go. So there are 56 different combinations you could have based on this scenario, okay? So if you have 8 cars and only a 3-car garage, you have 56 different combinations that you could create here, all right? Let's go ahead and take a look at our last problem. It's going to be a little more challenging. So here's our last problem, and it says the following. There are 4 freshmen, 4 sophomores, 3 juniors, and 5 seniors all trying out for the basketball team. It then says if the coach picks 2 freshmen, 3 sophomores, 3 juniors, and 4 seniors, how many different team combinations can the coach create? So again, we have a lot of information going on here, but it's really simple. You're just going to be doing this 4 different times. 1 time for the freshmen, 1 time for the sophomores, 1 time for the juniors, and then 1 time for the seniors. Then once you get the binomial coefficient for all 4 of those categories, you're just going to multiply them together and you'll get your answer. Okay, so for example, let's start with the freshman. What is my total? Well, my total for the freshman is 4. How many am I choosing? Well, if you go down to the second sentence, it says he's going to pick 2. All right, so we have a total of 4 and we want to pick 2. So what I'm going to do here is actually write out Pascal's triangle right here. That way I don't have to go back and forth. So why don't we go ahead and expand out Pascal's triangle right now real quick. Really simple, okay? And I'm going to go to the power of 4 on this diagonal. So here we go. This will be the last row that I do here. Okay, that's good. That should be sufficient for this problem. So again, the total is 4 and I'm choosing 2. So using Pascal's triangle here, I'm going to use this row right here because again, my total is 4 and I'm choosing 2. So 0, 1, and here we go, 2. So for the freshman, it's going to be 6. I'm just going to put F here is equal to 6. Okay. Now we're going to do the sophomores. Okay, so here we go. There are 4 sophomores. How many are we picking? Well, we're going to pick 3. I can see that right here. So we're using the same row, except now we're going to go to 3. So counting again, I have 0, 1, 2, and here's 3. Okay. So for our sophomores, we have 4 combinations. All right, let's go ahead and do the juniors now. And so with the juniors, we have a total of 3, and we're going to be choosing 3. Okay. So again, it's pretty straightforward. That's going to be 1 combination, but just so you can see on Pascal's triangle, if you go to 3 on the diagonal, that's right here, and then we're going to count to 3. So 0, 1, 2, 3, there we go. There's the 1, right? But again, that's pretty straightforward. So we're going to put 1 here. And then doing the seniors, what do we get there? So with seniors, we have a total of 5, and we're going to be choosing 4. So I actually have to expand out Pascal's triangle one more time. So I'm going to have here 1, and then 5, and then 10, 10, 5, and then 1, okay? So here's our new row. We're going to be choosing 4. So again, count to 4. We have 0, 1, 2, 3, and here's 4. So we get 5 combinations for the seniors, okay? There we go. From here, all you have to do is multiply these values together. And when you do that, that's going to give you the total amount of combinations that are possible. So if you do 6 times 4, you get 24 times 1, that's also 24. And then times 5, you get 120. So there's my answer, 120, okay? So there are 120 different combinations that could occur here based on this situation, all right? And that is it. So that is how you can use Pascal's triangle to solve these combination problems. But just understand what you're actually finding here is the binomial coefficient, okay? And when you get into the binomial theorem, this will make a lot more sense because the binomial coefficient is part of the binomial theorem, all right? And again, the binomial theorem is derived from Pascal's triangle. So if you can become proficient in Pascal's triangle, it's going to help you down the road because when you get into things like the binomial theorem, this material will be coming up again and you'll have a deeper understanding of it, okay? So that's going to do it for this video. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.